Let's take a look at the questions on homework night. The first topic is on congruence with rigid motions, and that is confirming that when a rigid motion is performed, that the shape maintains its same size and same angle measures. So we can watch figure V be transformed with two types of transformations and overlap figure W perfectly. So now we're going to fill in these drop-down menus by saying a translation, right? A translation followed by a rotation is what happened. So now all we have to do is watch the translation and count the amount of boxes, and that's translating 6 units to the left. So translate left 6 units, and then we're rotating in a counterclockwise position, and we rotate 2 quadrants or 2 quarter turns, so that's 180 degrees. The two figures are congruent because only rigid motions are used. We only used a translation and a rotation. Both of those are indeed rigid. All right, let's watch this one. A reflection and a rotation. A reflection over the x-axis, a rotation 1 quadrant, right, clockwise, 90 degrees clockwise. So first we have a reflection over the x-axis, followed by a rotation 90 degrees clockwise. The two figures are congruent because only rigid motions are used. The only one that's not a rigid motion is a dilation. And I didn't see that word anywhere yet. Alright, looks like I rotated and translated. So from the blue figure here, I rotate 90 degrees and I'm moving counterclockwise. So a rotation of 90 degrees clockwise, sorry, that's clockwise, followed by a translation let's see, I'm here. I'm going to go 1, 2, 3, 4 units up. Up 4 units. They are definitely congruent because no dilations were used. Alright, we're going to take a look at the second part here. Congruence by corresponding parts. So determine if the two figures below are congruent. And yes, they are. They are exactly the same shape. They're exactly the same size, but the figure is pointing in a different direction. So the two figures are congruent because only, it looks like a rotation was used. So only rigid, non-rigid motions. Only rigid motions. A rotation is a rigid motion. If you look carefully at letter C, which is here on the bottom side of the graph, and if it was rotating this way, then that means that the letter C, which is on the long bottom piece of this object, but coming down from this diagonal side, it looks like it would rotate over to L. So let's put that in, capital L, and submit. One more time. Let's see what happened with our shape here. Ooh, that's a totally different size. So that definitely is not congruent because a non-rigid motion called a dilation was used. Now we need to find the side that corresponds to from D to G. So from D to G is this long crooked side here, and if we were to find the match on the other shape, it would be this long crooked sides here. So what did they say? D to G. D to G. It looks like this shape was turned a different way here. Looks like it's turned a different way. So that would make it K to N. K to N. Make sure you're paying attention to the directions of your shapes. Third one is solving some equations. You're going to need a calculator for this. You're going to use an inverse operation to add these values to both sides. And then once you have just this fraction left, you can multiply both sides by the denominator and get 1.2 as your answer. Type it here and submit. Again, you're going to use your calculator to subtract these values. Sorry. To 3. And then you're going to compute. We've been doing that for a long time, so you should feel pretty confident with it. Let's go back and take a look at the next topic. Let's take a look at two-step equations with fractional coefficients. You'll definitely want to use a calculator for this part. So I'm going to add 1/4 to both sides. Your calculator can get those common denominators that you're going to need here. This would be 2/12, negative 2/12, and this would be 3/12, and we would get 1/12 over here. And then when we go to clear this coefficient, we're going to multiply by the reciprocal. For us, it's just known as 6. So y is equal to 6/12, which is the same as 1/2. The y was already typed for you, so you simply put your solution response there. Again, use your calculator to help you with the fractions, but we're going to subtract 3/7 from both sides, giving us negative 4/7 is equal to negative 1/4a. We're going to multiply both sides by the opposite reciprocal, so negative 4. This will get our a isolated, and this will give us 16/7. Alright, let's try determining if a set of points is a function. Remember, if you are a function, you have no repeating x values with different y values. So we want to know which one is not a function. So which one does have the repeating inputs with different outputs? And here it is. We have a repeating 9, but we don't have a repeating answer, right? So that is our non-function. One more time. This one is asking for when are they not a function? Well, they're not a function if an x value repeats with a different y value. So as you're scanning here, you're looking for repeating x values with different y values. Okay, last one here about functions. It is determine if this graph is a function. In order to do that, we use a vertical line and we scan it across our graph. We scan our vertical line across our graph like this to determine if it crosses more than one time. So as you can see, this does pass the vertical line test, so it is a function. Watch as the animation crosses the screen here. There it goes. It never touches the graph in more than one location at a time. Again, take your vertical line, scan the graph, choose if it is or is not a function. That means it passes or fails that vertical line test, and this one passes. So the last topic for us is going to be writing equations of lines. You're going to look carefully at the graph to find the y-intercept, and then you're going to count the rise and the run between two perfect corner points. So for us, we're going to write y equals, the y-intercept is 4, so I'm going to start with that. The line is going uphill, so I'm going to put a plus, and now I have to count the fraction for slope. Looks like it's up 2, 1, 2, 3, 4, 5. Up 2 over 5. Don't forget to put an x at the end. So 2 over 5 with an x off at the end, or to the side of the fraction. Again, identify your y-intercept first, -7. Then determine if your line is going uphill or downhill. And after your slope fraction, you need an x. So you can choose any 2 points you'd like. 1, 2, 3, 4, 5. 1, 2, 3. So 5/3 is our response. So y equals -7 plus 5/3 x. And that concludes homework 19.